Hello and welcome to Environment Variables, where we bring you the latest news from the world of sustainable software development. I'm the producer of this podcast, Chris Skipper, and today we're excited to bring you another episode of Backstage, where we peel back the curtain at the GSF and explore the stories, challenges, and triumphs of the people shaping the future of green software. We're no longer gatekeeping what it takes to set new standards and norms for sustainability in tech. This episode focuses on the Impact Framework, also known as IF, a pioneering tool designed to model, measure, simulate, and monitor the environmental impacts of software. By simplifying the process of calculating and sharing the carbon footprint of software, IF empowers developers to integrate sustainability into their workflows effortlessly. Recently achieving graduated project status within the Green Software Foundation, this framework has set a benchmark for sustainable practices in tech. Today, we have audio snippets from Navveen, Balani, Srinivasan Rakhunathan, the project leads, and Joseph Cook, the head of R&D at GSF and product owner for Impact Framework, to discuss the journey of the project, its innovative features, and how it's enabling developers and organizers to make meaningful contributions toward a greener future. And before we dive in, here's a reminder that everything we talk about will be linked in the show notes below this episode. So, without further ado, let's dive into the first question about the Impact Framework for Navveen Balani. Navveen, the Impact Framework has been described as a tool to model, measure, simulate, and monitor the environmental impacts of software. Could you provide a brief overview how this works and the inspiration behind creating such a framework?
Thank you, Chris. And thanks to all the listeners for tuning in. Let's first understand the problem we're solving with the Impact Framework. Software runs the world, but its environmental impact is often invisible. Every CPU cycle, every page load, every API call, these all contribute to energy consumption, carbon emissions, and water usage. Yet without the right tools, measuring and managing this impact remains a challenge. This is where the Impact Framework comes in. It's an open source tool designed to transform raw system metrics like CPU usage or page views into tangible environmental insights, helping organizations take action. Built on a plugin-based architecture, it allows users to integrate, customize, and extend measurement capabilities, ensuring scalability and adaptability. More importantly, the Impact Framework helps realize the software carbon intensity specification, making sustainability reporting transparent, auditable, and verifiable. Every calculation, assumption, and methodology is documented in a manifest file, ensuring that impact assessments are replicable and open for collaboration. At its core, the Impact Framework is built on a simple yet powerful idea. If we can observe it, we can measure its impact. And once we can measure it, we can drive real change, reducing emissions, optimizing resource use, and building truly sustainable software.
What were some of the most significant technical or organizational challenges you faced during the development of the Impact Framework? And how did you and the team overcome them?
The Impact Framework wasn't just built, it evolved. It was shaped by real-world challenges, lessons learned, and the need for a scalable, transparent way to measure software's environmental footprint. The foundation of the Impact Framework was laid through previous projects and ideas, starting with SCI Open Data, which tackled the lack of reliable emissions data, and SCI Guide, which helped organizations navigate different datasets and methodologies. Another critical component was the SCI Open Ontology, which defines relationships between architecture components, establishing clear boundaries for calculating measurements. Alongside these foundational efforts, real-world use cases from member organizations applying software carbon intensity measurement played a crucial role. These practical implementations tested SCI in diverse environments, refining methodologies, and ensuring that SCI calculations were not just theoretical, but applicable and scalable across industries. But data alone wasn't enough. We needed to scale measurement across thousands of observations. Sustainability assessments had to be continuous, automated, and seamlessly integrated into software development. This led to key innovations like aggregation, which enables organizations to condense vast amounts of data into meaningful, structured insights, rolling up emissions data across software components to provide a holistic system-wide view. Technology, however, was just one piece of the puzzle. Adoption was equally critical. To accelerate real-world impact, we opened up the impact framework to our annual Carbon Hackathon event, where teams worldwide built projects that pushed its capabilities. This was a turning point, validating its flexibility and refining it through community-driven development. At its core, the impact framework is built on transparency. Unlike black box solutions, every input, assumption, and calculation is fully recorded in a manifest file, making assessments auditable and verifiable. This commitment to openness has been crucial in building trust and driving adoption.
Looking ahead, what are the next steps for the impact framework? Are there specific new features or partnerships on the roadmap that you're particularly excited about?
That's a great question, Chris. Looking ahead, the impact framework is entering an exciting new phase with a major focus on expanding measurement capabilities for AI. Right now, we're working on the SCI for AI specification, which extends software carbon intensity to both classical AI and generative AI workloads. Measuring AI's environmental impact comes with a new level of complexity. AI isn't just another software workload. The environmental footprint varies significantly depending on whether you're training a model from scratch, fine-tuning a large language model, or simply using an AI API like ChatGPT or Gemini. Each scenario has different compute demands, memory requirements, and energy consumption patterns, making standardized measurement both challenging and essential. Through the impact framework, we aim to tackle this by developing new plugins and contributions that enable precise measurement of AI-related energy use, hardware efficiency, and emissions across training, fine-tuning, and inference workloads. These capabilities will collectively evolve through community participation with researchers, developers, and organizations contributing to refining methodologies, expanding datasets, and ensuring that AI measurement remains transparent, auditable, and standardized. This collaborative approach will allow organizations to quantify, compare, and optimize their AI workloads, making sustainability a key consideration in AI deployment. Beyond AI, we are also exploring new partnerships to further enhance the impact framework's adaptability. Collaboration with cloud providers, software vendors, and sustainability researchers will be crucial in ensuring that the framework evolves alongside industry needs. Our goal is to make environmental impact measurement not just an option, but a fundamental part of software and AI development at scale.
Moving on, we have some questions for Srini. Srini, IF emphasizes composability and the ability to create and use plugins. Could you explain how this innovative approach has enabled more accurate and flexible environmental impact calculations for different types of software environments?
Absolutely. The impact framework's emphasis on composability and the use of plugins is actually a game changer for different environmental impact calculations. If you notice that the framework is highly modular, making and allowing users to create and integrate various plugins. What it means is you can tailor the framework to fit the specific needs of your software. And it doesn't matter what type of software you have. whether it's cloud-based, on-prem, or hybrid. What is also advantageous is that the plugin ecosystem has a wide range of tasks. For example, it has something around data collection, it can do impact calculation, it can do reporting, it can do also very, very specific tasks like math functions and aggregation functions. What this means, you can mix and match plugins to create a mashed up pipeline that reflects your environment, whether you are running your software on web, cloud, mobile, doesn't really matter. As long as you know what your software boundaries are, you will be able to combine these plugins and create your own pipeline, if you will. And that pipeline will help you create your calculation pipeline that can either run one time or run as a batch or run based on certain triggers. What it also means, and if you notice, there is also manifest files, and we will be talking more about it later in this conversation, is that the manifest files ensures that you have a repeatable way of calculation. I mean, you mash up these different plugins and you create a pipeline and you embed it in a manifest file and it's repeatable. So what I think is this framework's capability of composability and plugin can help you make very, very accurate impact calculations.
How have collaborations with organizations like Accenture and Microsoft, as well as the open source community, contributed to the success of the Impact Framework? Are there any standout moments or partnerships you'd like to highlight?
Thanks, Chris. That's a great question. So the cornerstone of the success of Impact Framework has been collaborations. And this has been ongoing from the time this project was conceptualized. Bear in mind that when we, Navveen, who's there also with us, and I, along with the other, Joseph and Asim, started thinking about the project, the initial vision of the project was very different. So we started off with something called SCI Guide, where we wanted to collate data sets across the open source community to help calculate emissions from software. And we built the SCI Guide, and that transitioned into something called CarbonQL, which is a primitive version of what we see today in the Impact Framework, which is more like, how do we make sure that it is easier for users or developers to calculate emissions from software? And the learnings that Navveen, Joseph, I, and Asim went through to come up with the initial version of Impact Framework and the amount of work that the team has put together to get it to graduation state is amazing, and it speaks volumes about the collaborations that has gone ahead into the building of the tool. One particular highlight I want to call out is every year GSF organizes what is called the CarbonHack. And in 2024, the CarbonHack focused on getting the open source community to come and build tools on top of Impact Framework, either extension of the tool or building content or newer areas where the Impact Framework can be used. And you would be amazed at the amount of contributions that came in. And newer use cases that looked at calculating emissions, not just from carbon, but from water and other forms of renewable resources was also identified. And that I believe was a standout moment for the tool.
The IF documentation highlights the use of a manifest file and a CLI tool to calculate environmental impacts. Could you walk us through how these tools work and how they lower the barriers for developers to adopt sustainable practices?
Definitely. We can talk about both the CLI tool and the manifest file. These are actually cornerstone capabilities built within the Impact Framework, and they help us to calculate the environmental impact. What happens is the manifest file contains a list of the software's infrastructure boundary encoded as YAML files. It's in the standard YAML format, and it contains every bit of component that is part of the software, whether it's front end, middle tier, back end, database, API, everything encoded as what's the hardware used, what's the utilization, what's the telemetry involved. So much so that it can be used to give us an input to the Impact Framework CLI tools that calculates emissions. The use of the file enables transparency and rerunability. That means it can allow anyone to re-execute the manifest file and everyone will come up with the same calculations. The second piece that we spoke about, which is a CLI tool. It's a command line tool, which means it can be used to run on any environment. It processes the manifest file and computes the environmental impacts. So the way it works is developers can pass the path to the manifest file to the CLI tool, and it will take care of the calculations. The tool has capabilities to do phased execution, and that allows efficient and flexible use of the framework.
And finally, what lessons have you learned from working on this project that might benefit other teams looking to build tools or frameworks for sustainability in tech?
Thanks for asking this question. At an over level, I would like to respond to this question by focusing on lessons learned from two aspects. The first is the execution model, and the second will be the technical design. In the execution model space, this project is a good example of how open source collaboration works. The team used GitHub extensively, and most of the meetings were asynchronous. And the engineers and the product managers and everyone who worked on the project worked through GitHub and collaborated extensively using the open source tools available, which is a great model for scale. The second aspect we should look at from an execution model, and which is a success story here, is how the team used customer feedback as inputs to make the product better. There were constant, if not many sessions with many customers with whom the team worked to engage with them and understand what the requirements are for building a tool that can help them calculate emissions and use that feedback into the process, into the backlog to make the tool better. The second aspect of lessons learned will be on technical design. And here I would want to call out that the whole concept of building a plugin ecosystem and make them composable such that you have a set of plugins that you deliver to the community, like a base framework, and then you allow extensibility. So that's a great model which can help tools that can use sustainability as a calculation engine. And then the second piece which is also equally important. As you do this, you also make sure that you have extensive and good documentation that can help anyone who's coming on board understand the framework and be able to get on board and run with building a new plugin as soon as possible. The IF code, the GitHub site, if you go there, you will have a link to the docs page. And if you read through the docs, it's very, very self-explanatory and will allow anyone who can come in and who's interested into building a plugin, do that at the fastest possible time. So these are, in my mind, lessons learned both from an execution model and the technical design aspect.
Moving on, we now have some questions for Joseph. Joseph, the Impact Framework recently achieved the status of a graduated project under the GSF. What does this milestone mean for the project, and what were some of the key factors that led to its graduation?
The Impact Framework graduation was a huge milestone because it represents the moment when the project is considered sufficiently mature that it no longer needs to be incubated, and instead it can largely be handed over to the community. We consider the software to be feature-rich and stable enough that people can integrate it into their systems. And in order to graduate, the project had to meet a quite stringent set of requirements, including demonstrating that Impact Framework had real-world users, and that we had addressed community requests and bug reports, and that we had suitably comprehensive test coverage, and that the documentation and the onboarding materials were all fit for purpose. Now that milestone has passed, development activity is going to be much more ad hoc and driven by the community rather than following a development roadmap that's defined by Green Software Foundation. Our efforts at the GSF will now be in driving adoption instead.
How does the Impact Framework engage with the broader tech community to encourage adoption? Can you tell us what steps the GSF is taking to include the community as part of the IF development?
Impact Framework is used by all kinds of organizations, but it also has a thriving open source community. And most of the discussion with the community happens on GitHub, either through issues or on the discussion board. But we also have a Google group where we share updates and collect feedback. Open source development on Impact Framework is really fundamental. It's really baked into the very core of the project. Instead of trying to ship Impact Framework with all the built-in features to connect to thousands of different services and systems that people want to measure, we instead focused on making it really easy to build plugins and then encouraged an open source community to develop, where people create their own plugins for all the features that they care about and share them with each other on our Explorer website, which is like a free marketplace for Impact Framework plugins. This model actually makes the Impact Framework much more robust and much more stable because we have a much greater diversity of voices influencing what Impact Framework can do and what it can connect to. It decentralizes the development of the project without compromising the core software. And it also means that our small development team doesn't shoulder the burden of maintaining a huge code base with lots of different brittle connectors to third-party APIs and services. And going forward, we want to keep this community thriving and see thousands more Impact Framework plugins listed on the Explorer.
How do you see the Impact Framework setting new benchmarks for environmental responsibility in tech? Are there specific metrics or practices that you believe will influence industry standards?
Impact Framework is a lightweight piece of software for processing what we call manifest files. These are YAML files that follow a simple format that captures the architecture of the system that you're studying, all the observations that you've made about that system, and all of the operations that are applied to your data. I like to refer to these files as executable audits because they mean that you don't just report emissions numbers anymore, you actually show your working too. And this enables the community to fork and modify your manifests and challenge you. And through iteration, you can come to crowdsourced consensus over your environmental reports. We would love to see this radical transparency become the gold standard for environmental impact reporting for software. Not only that, but manifests can be the basis for experimentation or forecasting and help decision makers to assess the environmental benefits of implementing some change. Imagine you're challenged about why you chose some specific action. Your manifests are your evidence. And we think this combination of transparency and reproducibility, composability, and openness is a unique selling point for Impact Framework, and it could transform the way projects and organizations report their emissions and introspect their own operations.
For listeners who are interested in getting involved with the Impact Framework, what are the ways they can contribute or support the project? Are there specific skills or areas where the community can make the most impact?
If you would like to get involved in Impact Framework, there are many ways to do so. If you're a developer, you can head to the GitHub, where we have plenty of open issues, including some specific good first issues to help people get started. If you want to build plugins, then you can download our template and use that to bootstrap your way in, and then submit your plugin to the Explorer using a simple type form on our website. We always appreciate updates to the documentation too. And if you're interested in integrating Impact Framework into your systems, you can always reach out to research@greensoftware.foundation to discuss it with us directly. We're always happy to help. If you just want to test the water, we have general questions about Impact Framework. You can start discussions on our GitHub discussion board or communicate via our Google group, if-community@greensoftware.foundation.
Awesome. So I'd like to thank Navveen, Srini, and Joseph for their contributions to this episode. Before we finish off this episode, I have a few events that need announcing. Starting us off, we have an event that will be happening today, the date of the publication of this episode, February the 13th, 2025, at 5 p.m. CET in Utrecht, Netherlands. Any Netherlands-based listeners, you're invited to a Green Software Community Meetup today from 5 p.m. until 8 p.m. at Werkspoor Kathedraal, Join us for a free in-person event to kickstart a more sustainable year in tech. You'll hear insightful talks about reducing your software's energy footprint, scaling down for greener computing, and building a grassroots digital sustainable movement. This is a great opportunity to connect with like-minded professionals, share ideas, and be part of a growing Dutch community that's dedicated to building a greener tech future. Food and drinks are provided free of charge. Next up is an event in Brighton in the UK happening on February the 19th from 6 p.m. to 8 p.m. at Runway East, which features Senior Digital and Sustainability Manager for OVO, Mark Buss, speaking about the challenges with advocating for digital sustainability within his company. The talk will also be live streamed, so we will have a link in the show notes below for that. Next up, for any Spanish listeners, we have the first ever meetup of the green software community in Spain that will be happening online at 6 p.m. CET on February the 20th. Dia Zero, Comunidad Meetup, Green Software Foundation España will be a chance for you to discuss how to collaborate with other people passionate about climate change and green software, and we'll have a link to that in the show notes below too. Next up, down under in Australia on February the 20th at 6 p.m. AEDT in Melbourne, we have Digging Deeper into Digital Sustainability, How to Design and Build Tech Solutions. This will be happening at ChargeFox. Catherine Buzzer will be talking about the impact that software is having on the world's carbon emissions and how to align your career in tech with the decarbonized future we can all play a role in creating. Next up, another UK event on February the 27th at 6 p.m. GMT in London. Practical Advice for Responsible AI will be held in person at the Adaptivist offices. Talks about green AI with Charles Humble and AI governance with Jovita Tam. Click the link below to find out more. And finally, on our events list, we have GSF Oslo. Will be having its February meetup on the 27th of Feb at 5 p.m. in person at the Accenture offices from 5 until 8 p.m. Come along to find out how leveraging data and technology can drive sustainability initiatives and enhance security measures, and dive into green AI. Talks from Abhishek Dewangan and Johnny Morland. Details in the podcast notes below. So that's the end of this episode about the Impact Framework project at the GSF. I hope you enjoyed the podcast. To listen to more podcasts about the Green Software Foundation, please visit podcast.greensoftware.foundation, and we'll see you on the next episode. Bye for now.